This lesson is graphing rational functions. It is reviewed from Algebra 2. If you remember that, that'll help. If you don't, here's how you do it. So we have a rational function. It's called rational because of the ratio with a variable in the denominator. This one has 3 vertical asymptotes because anytime the denominator equals 0, then it's undefined. And in this case, it's a vertical asymptote. So what you do is you take each factor, set it equal to 0, and solve. So that's why you have a -4 and -2 and +3 vertical asymptote. And so you always start on the right side at the top and graph the curve. On the far right and the far left, they kind of look like those boomerang curves. And because it's positive, you start at the top. So you go right to left. When you hit the vertical asymptote, you go to the opposite side. So in this case, it's going towards positive infinity. And then once you hit the vertical asymptote, it jumps to the opposite side. And then you have that curve down there, because we also have this horizontal asymptote. And then here it's going towards negative infinity, so it jumps to the opposite side. And then here it's going up, so when you hit the vertical asymptote, you go back down. And it's the far left, so that's the one that looks like a boomerang. So we're done with that graph. Then you have the rational functions where you have a factor that's in both the numerator and the denominator, so they cancel out. It is still undefined at -2, but with this, for the sketch, we cancel those out to have 2 vertical asymptotes, one at -4 and one at +3. Same thing, start at the top. You hit the asymptote, you jump to the opposite side. You hit this asymptote, so you jump to the opposite side. And the difference this time is it is undefined at -2. So we come over here, and it's a whole because it's undefined, but because it was both in the numerator and the denominator and then cancels out, it's not a vertical asymptote anymore. So for this one, the factor in the numerator does not cancel with 1 in the denominator, so that means it's an x-intercept. So for this one, we do have 3 vertical asymptotes, and x equals 3 is your x-intercept. So it's positive, so on the right side you start at the top. And since this is going towards positive infinity, you hit the vertical asymptote, so you go to negative infinity. And then you're going to go up and then through that x-intercept and then up towards the next asymptote. And then again, this one's going up, so the next one goes down. This one's going down, so the next one goes up.